Hello, my name is Erica Lopez.
And my name is Marlene Castro, and together we worked on building our autonomous Arduino track robot. Introduction. Arduinos are a beginner-friendly, open-source microcontroller hardware and software. Its versatility allows for it to read inputs and turn it into an output that can control relays, LEDs, servos, motors, etc. Our project entailed the construction of an autonomous car robot, distinguished by its capacity to navigate its environment autonomously while simultaneously avoiding crashing into potential obstacles. We achieved our goal by implementing the correct hardware necessary, such as our sensors that detects obstacles and displays their distance on our LCD display. Here on the left, we have an image of our Arduino megaboard. Experimental Setup Hardware Part 1. Assembling our hardware components proved to be a challenging yet gratifying endeavor for the team. We began by constructing our track car chassis from scratch, which included putting together our wheels, tracks, motors, and battery pack. Once the car was built, we mounted the Arduino Mega 2560 board and motor shield on it. This will serve as the foundation of our robot. Next, we created a custom-built sensor shield. We achieved this by carefully gluing the sensors on each side of the shield board and soldering the wires onto it to ensure that they are secure. Then, it was mounted onto our motor shield. On this slide, we present the labeled hardware components that make up our autonomous Arduino robot. The motor shield, which appears on our left, controls the two DC motor speed and direction. Equipped with sensors, our robot detects potential obstacles, enabling precise maneuvers to avoid collisions. Next is the LCD screen, which showcases the real-time sensor readings so we know what's going on. The Arduino Mega that you see here is the microcontroller, aka the brains of this project. And then we have the voltmeter, which monitors and displays the battery voltage, and on the right, we see an image of our project before mounting the sensor shield. And to the right of that, we have the sensor board.
For our experimental setup, our software, the parts we highlighted on the slides is the LCD display, as it plays a big role in showing the user how the car is working. The LCD display does what is in the name. It displays information onto the screen. An example of how the LCD display looks like is in our third slide, where the third picture, the sensor readings, shows how the car detects from the sensors that it has. For our code, we have a function setup, which simply sets up the basics of what will be shown on the screen. This function controls the text size and the text color. For our second slide on the software, we decided to highlight how the car moves and the functions specific to that. The code that we have again is functions that gather the distance from the sensors. As seen in the code, if the car detects that the distance is greater than what we have set, it will continue moving, and once it detects a distance that is less than what we have entered, it will stop moving. And all of these things will be shown on the LCD screen, detecting the distance. When the car detects a certain distance and decides to make a turn or move forward, it will show that onto the screen by showing either turning left, turning right, or stopped.
Results. The autonomous Arduino track robot demonstrated good performance in navigation and obstacle sensing and avoidance. The sensors were able to detect obstacles and the robot autonomously avoided them. The sensor readings provides the user with accurate information about its direction and status. The voltmeter we incorporated into our robot monitors the battery voltage. Conclusions and recommendations. Our project was completed and executed our code accordingly. The completed Arduino track robot was able to sense obstacles in its way and autonomously avoid them. Upon completing this project, I learned how to use Arduino and the importance of it. My team successfully programmed our robotic car to operate autonomously, which I believe is very useful to learn about since artificial intelligence is growing in our world today. If given more time, I would add more modifications to my Arduino project. For example, adding arms would allow it to interact with the environment and be used to retrieve objects. Adding a camera and allowing it to record can be useful too. Adding speakers and implementing human-robot interaction features would be cool to use. I believe that this is an important base project because it introduces the idea of artificial intelligence to the student, which is gaining traction in popularity. Exploring artificial intelligence not only opens up career opportunities, but also ensures individuals are prepared for the ongoing advancements in the field. Artificial intelligence is expected to continue advancing, so it is important to stay informed and prepared for the future.